Hello everyone, welcome to S3 Part 1. Simple storage service is one of the most important topics as far as certification is concerned. This is our agenda. We'll talk about pre-S3 a little bit, then we'll also do a recap on API. I'll give you the introduction on S3, then different consistency models which are followed by S3, then examples and API introduction, and then we'll conclude our Part 1 with a demo. There's not much to talk in the pre-S3 section. If you know what online cloud storage is, you know what S3 is. But of course, in S3 you get a lot of other things to do. Online storage is something wherein you can upload your files, folders, images, videos, songs from your local machine and access it from anywhere in the world. All these are online storage providers. Why are we using all these products nowadays? Because they provide a lot of flexibility, security, durability. You can upload your important documents once and can access it from anywhere as long as there is internet connectivity. That is not the only selling point of these providers. The documents or data we store are highly durable and secure. In olden days, we used to store our important documents, pictures, favorite movies, and videos, etc. in external hard disks, which were highly unreliable. You'd never know when those can go corrupt. I still remember I had stored more than 100 GB of music files on one of my hard disk drives, but suddenly one fine day, when I tried to access that drive, it started saying that data cannot be read, you have to format your disk. I literally lost all those songs. If you use these online storages, you can be rest assured that your data will never be lost or will never get corrupted. I have already talked about APIs in the introduction part. Please go through it again. Here we'll just do a recap. What are APIs? Suppose you have written a program in any of the programming languages. It can be any other language apart from what I have mentioned here. This program caters to one or more of your application's functionalities. You want this program to be called from some other program written by developers from other team or other part of your application at large. What we'll have to do is expose an API, and this API would be used by programs or other developers to access your program's functionalities. An API is a list of specifications which describes how information is exchanged between programs. So software that wants to access another will call the API published by the other program. In our case, this is the program, it has published an API, and this is another program which is using this API to access the functionalities provided by this program. That's all about pre-S3 talk. Let's jump into S3 right away. Simple storage service is storage for internet, similar to the other products like Google Drive, iCloud, Dropbox, etc. But S3 gives us a lot more control and can be used in programs. S3 provides web service which can be used to store and retrieve unlimited amount of data. S3 is used to store mainly binary objects. By binary objects, I mean videos, pictures, movies, songs, PDFs, Word documents, Excel files, etc. Before going into S3, I want to get the stage right with consistency model. S3 provides highly durable and available solution by replicating all data in multiple data centers in a region. When S3 stores your data, which can be any binary object, those are typically stored in multiple data centers using replication. Data uploaded in a particular region never leaves that region. There is something called read after write consistency which is provided by S3. This is the first consistency model provided by S3. And this is the second one, which is eventual consistency. Continuing with the consistency model, let's see how read after write consistency works. Remember one thing, this consistency model works only for new data or files or objects. In web service term, it is called new puts. Put method is used to upload new object or file or to overwrite existing files. That's why you have new puts and overwrite puts. S3 will be used to store your data. Data is stored in a single region and across multiple data centers. Data can be uploaded from anywhere, either from internet or from EC2 instances in VPC. Data to be uploaded is put in S3. The file is sent to S3 and S3 stores the file in multiple data centers. So the same data is replicated in multiple data centers in the same region. Success message of upload will only be sent after that. That means until and unless the file is not replicated across multiple data centers, the upload will not be successful. Let's see eventual consistency model. This is used for updates or deletes of files or objects. We'll use S3 to update or delete files. The file is there in a single region across multiple data centers using replication. You're trying to upload the same file again or trying to delete the file. You put your file and S3 overwrites or deletes it in a single data center. Once that is done, the success message is sent. See, this time S3 did not wait for this update or delete to get replicated across all data centers. Now suppose you want to read this file just after the update or delete was done. It might happen that S3 gets this file from this third data center. When you get it back, it might not be the updated one because replication has not happened yet. If delete operation was used on this file instead and you got a success message and the delete operation was not replicated to all the data centers, S3 still might fetch you this file. You'll get the correct output if you try read operation again after some time. This is called eventual consistency. You can mention during read whether you want consistent read or eventual consistent read. In case of consistent read, S3 will check all data centers and return the most updated data. But for eventual consistent reads, S3 will pick a data center at random and return the data from there without checking whether it is the updated one or not. Here are some of the points of differences between two consistency models. In consistent read, you will not get any stale reads. Eventual consistent reads, stale reads are always a possibility. Read latency is higher in case of consistent reads because S3 will check all the data centers, but eventual consistent read it is pretty lower because S3 will read data from any one of the data centers. Read throughput is comparatively lower in consistent read for the reason mentioned earlier, and it is faster in eventual consistent read. Let's understand consistency model using examples now. How concurrent applications will behave with S3's consistency model. Concurrent applications are those which run at the same time. This is our timeline, start to end. Upper half belongs to application 1's timeline and lower half belongs to application 2's timeline. Suppose application 1 does some write operation W1. Application 2 does another write operation W2. W1 updates name field to EC2 and W2 updates it again to EBS. Application 1 does a read operation R1 at this time, followed by another read operation R2 by application 2. For a consistent read, R1 and R2 both return name as EBS. For an eventual consistent read, R1 and R2 might return name as either EBS or EC2 or no results, depending on the amount of time that has elapsed. Another example, but this time around, W2 does not complete before the start of R1. Therefore, R1 might return name as either EBS or EC2 for either a consistent read or an eventual consistent read, because replication might not have been completed across all or any of the data centers. Also, depending on the amount of time that has elapsed, an eventual consistent read might return no results. Let's take a feel of S3, what it is now and how files or data are uploaded to S3 using a demo. We'll also see how files which have been uploaded can be accessed. I have a few pictures in my folder AWS-Foundation-S3 drive. I'll upload some of these pictures in S3. Click on Services, go to Storage and you can find S3 here. Or else you can use the search bar. Before uploading the files, you'll have to create something called a bucket. We'll discuss bucket in our next part. Click on Create Bucket and give it a name. We'll create the bucket in US East 1 or North Virginia region. Click on Create. The bucket has been created. Hover around the name and click on this bucket to go inside it. Here you can upload your files. Click on Upload and then click on Add Files. I'll use my drive to upload a few files. Let's upload the picture of Superman. You'll see the status here. It is taking some time because this object or this file is being replicated across multiple data centers. Now the object has been uploaded or the picture has been uploaded. Hover around the name and click on this picture. This is the link which can be used to access this picture. Before doing so, we'll have to change the permissions. Click on permission and click on everyone, and here select read object. We'll discuss all this in due time. As of now, I just want to give you an overview. Once you copy this URL, go to your web browser and paste the link, which will show you the picture. You can upload multiple files also. You are uploading 3 files at one go, or 3 objects in a single operation. So all 3 files are being uploaded. It will take some time, as I said, because the object is being replicated across multiple data centers. It is done. You will access the object using this link. Before that, change the permission. This object is being read from the S3 bucket. That's all for this part. Thanks for watching.